Yes. Hello everyone. This is D. Chinnagokari. I am going to explain about solutions in this chapter. So first of all, solution. So what is a solution? Here solution is nothing but a homogeneous mixture. Homogeneous mixture. Homogeneous mixture of more than one substance is called solution. So when you see the classification of matter, so we already know matter classified into physically and chemically. When you see the chemical classification of matter, matter is classified into pure matter and impure matter. Pure matter and impure matter. See here, impure matter is again classified into two types. Impure matter is also called, it is mixture. This again classified into two types, that is homogeneous mixture and heterogeneous mixture. So here homogeneous mixture is called solution, or sometimes it is also called true solution. And here heterogeneous mixtures are again classified into two types, that is colloids and suspensions. So here what is the difference between the solution, colloid and suspension? Means solution is a homogeneous mixture, or whereas colloid and suspensions are heterogeneous mixture. Here the particle size is more when you compare to the solution, right? So now solution can broadly divided into two types, that is means solution contain two parts, solute and solvent. Here what is a solute? Solute is the minor quantity, whereas solvent is the major quantity. See, for example, when you take the water and when you pour some amount of NaCl, that is sodium chloride, in it. So here after dissolving the sodium chloride, we cannot find out the sodium chloride particles separately. Why? Because this NaCl distributed throughout this solution uniformly, means which by seeing with our naked eye we cannot say where the solute particles and solvent particles are exactly present. Why? Because they are mixing very uniformly. Such type of mixtures are called homogeneous mixtures. These homogeneous mixtures are called solutions. In this solution, the major quantity, so here water is the major quantity, it is called solvent, and the sodium chloride NaCl is the minor quantity, it is called solute. So here sometimes solution is a mixture of solute plus solvent. It is a homogeneous mixture of solute and solvent. So next let us discuss about classification of solutions. First, we can classify the solutions based on the number of substances present in a solution. So we already know solution at least should contain two components. So the first one is binary solution. First one is binary solution. Binary solution means which contain only two substances, that is called binary solution. Example we can take, number of examples are there. For example, NaCl plus H2O, H2O plus C6H5, OH, ethanol, etc. So this is a binary solution. And next to ternary solutions. Ternary solutions. Ternary solutions means which solution which contain three substances in it, that is called ternary solution. Example, NaCl plus sugar plus water. This is called ternary solution. Next to quaternary solutions. Quaternary solution. So here what is a quaternary solution? Solution which contain four substances in it, that is called quaternary solution. Example, NaCl plus H2O plus KCl plus MgCl2, magnesium chloride. All these are the examples of what? Quaternary solutions. This is based on the classification of solutions based on number of substances present in it. Based on the number of substances present in it, we can classify the solutions like binary solutions, ternary solutions and quaternary solutions. Next classification, that is based on solvent. Based on the solvent, we are having two type of solutions. The first one is aqueous solutions. Aqueous solutions means if the solvent is water, that is called aqueous solution. For example, KCl plus H2O, the aqueous potassium chloride, or HCl plus H2O, that is aqueous hydrochloric acid. Next to non-aqueous solutions. Non-aqueous solutions. So what is a non-aqueous solution? Means if the solvent is not water, if the solvent is not water, that is called non-aqueous solution. For example, we can take benzene, C6H6, benzene, CCl4, carbon tetrachloride, chloroform, CHCl3, etc. All these are act as non-aqueous solution. For example for non-aqueous solutions, benzene plus C6H6 plus CCl4, carbon tetrachloride. This is one of the mixture of example for non-aqueous solution. And benzene naphthalene, C6H6 plus naphthalene. This is also one of the example of non-aqueous solution. So this is based on the solvent. Based on solvent, we have two type of solutions. One is aqueous solutions, another one is non-aqueous solution. Aqueous solution means if the solvent is water, that is aqueous solution. Non-aqueous solution means if the water is not a solvent, that is called non-aqueous solution. Next classification is based on the physical state of solute and solvent. So here physical state means solid, liquid and gas. We already know they are the physical states. Based on the physical states, mainly we have three type of solutions. They are solid solutions, solid solutions, liquid solutions, liquid solutions and gaseous solutions, gaseous solutions. So here solid solutions means solvent, solvent is solid and solute may be solid, liquid and gas. Solute may be solid, liquid or gas. Solid solutions solvent, solute. Example. So here in solid solutions always solvent is solid, solvent is solid. Okay, just reverse it. Solute, solvent, solute and solvent. So here in this type of solutions solvent is always solid. Here solute may be gas, liquid or it may be a solid also. First type of solid solutions here, that is gas in solid. Gas in solid type of solution means gas is the minor quantity, solid is the major quantity. This is example. Here we can take occlusion of H2 gas over platinum or over metals. Simply we can write over metals which act as the catalyst over metals. Next liquid in solid, for example amalgam, for example amalgam for Hg in gold, mercury Hg in gold or Hg in sodium. All these are the examples of liquid in solid type of solutions. Next solid in solid, solid in solid type of solutions we can take alloys. For example 22 carats gold, alloys are the examples of solid in solid. Here both solute and solvent both are solids only. For example 22 carats gold, 22 carats gold is a combination of gold plus silver or sometimes they use copper also. This is about solid in solid. So here solid solutions again three types, that is gas in solid, liquid in solid, solid in solid. Here solvent is means major quantity, always solid. Such type of solutions are called solid solutions and the solutions are also present in the solid state only. The solutions are also present in the solid state only. Next liquid solutions means if the solutions are present in the liquid state they are called liquid solutions. Here which means solvent is always it is liquid. So solute may be gas. Here gas in liquid, example CO2 in water or carbonated drinks or soda water are the examples of gas in liquid. Next liquid in liquid means solute is liquid, solvent is also liquid. We can say example C2H5OH plus H2O, C2H5 plus OH and H2O, C2H5, this is nothing but ethanol plus water or acetone plus water, acetone plus H2O. This is also one of the example of liquid in liquid type of solutions. Next solid in liquid, So solid in liquid, for example NaCl plus H2O means NaCl is dissolved in the water. This is an example of solid in liquid, means finally the solution is present in the liquid state, that's why they are called liquid solutions, and there the major part is liquid in liquid solutions. Next, gas solutions means the major part is gas, means the solvent is gas, and the solutions are also present in the gaseous state only. So here these are also three types, that is gas in gas, gas in gas. Gas in gas means solute is also gas, solvent is also gas. For example, O2 in N2, O2 in the N2. Oxygen present in the air. In the atmosphere, we already know 78% of oxygen is there, 21% of 78% of nitrogen, 22% of oxygen is there. So that's why gas in gas, one of the example, air, that is O2 in the N2. Next, liquid in gas. Liquid in gas, for example, chloroform, CHCl3, chloroform in air, or chloroform in N2, chloroform in N2, or chloroform in air also we can take as the liquid in gas type of solution. So here chloroform evaporates and small droplets of chloroform are present in the air. That is called what? Liquid in gas type of solution. It is one of the example of what? Liquid in gas type of solution. Finally, the solution is present in the gaseous state only. Next, solid in gas. Solid in gas. For example, camphor. Camphor in air. We already know camphor is a sublimizable solid. So this camphor sublimizes and turns into small solid particles and it mixes into the air. So that is nothing but example of solid in gas, camphor in the air. So this is based on the physical state classification of this classification is based on the physical state of solute and solvent, or sometimes this is also called physical state of class based on the physical state of solution. So solutions may be mainly three types, that is solid solutions, liquid solutions, and gaseous solutions. Again, each type of solution is categorized into three types, which means based on this physical state of solution or solute and solvent, there are 9 type of solutions are there. Yes. Next classification is based on the amount of solute present in the solution. So here based on the amount of solute present in the solution, here solutions are again classified into three types. They are, first one is saturated solution, saturated, unsaturated, and supersaturated, saturated, unsaturated, and supersaturated. So here, so let us consider we are dissolving some solute in a liquid, for example, we are adding NaCl to this water. So when you are adding NaCl to this or not like NaCl, you take sugar in the water. So when you are adding sugar to the water, initially when you add just few amount of sugar to it, the total sugar dissolve in it. And first let us consider we are adding 10 grams of sugar, and total sugar is dissolved, and again 10 grams we are adding, like that. When you are adding 10 grams after particular quantity, the water cannot dissolve no more solute in it. Such type of solutions are called saturated solutions. So here how we can say, first initially what we are doing, we are taking water H2O, and the H2O we are adding sugar with a little quantity. Gradually we are increasing the quantity of sugar in the water, so that initially it is dissolving the sugar in the water. So after the certain quantity, this water cannot dissolve no more sugar in it. Such type of solutions are called saturated solutions. So how we can define a saturated solution? So the solutions which cannot dissolve, no more solute in it. The solution which cannot dissolve, no more solute in it are called saturated solution. No more solute it can dissolve in a solution saturated. No more solute dissolved in it are called saturated. So here at a particular temperature. And what is unsaturated solution? Means the solution which can dissolve more amount of solute in it. The solution which can dissolve more amount of solute, in it. That is called what? Unsaturated solution. Then what is a supersaturated solution? So here we already know saturated. So in this saturated solution we are going to dissolve more amount of solute in it by heating. So such type of solutions are called supersaturated solution. So the solution which contain, or the solution which is prepared by heating, saturated solution by adding more solute, that is called what? Supersaturated solution. So here these are the three type of solutions based on the amount of solute present in it. In saturated solutions means based on this we have three type of solutions: saturated, unsaturated and supersaturated. In saturated solutions the solution which contain exact amount, means there is no more solute we cannot dissolve further, that is called saturated. Unsaturated means still we can dissolve more amount, which means the solution contain less than the solute what it is required. Supersaturated means the solution which contain more amount of solute what it is required, that is called what? Supersaturated solution. So this is about saturated, unsaturated and supersaturated solutions. Next we will discuss about the methods of expressing concentration. So here what is concentration? Concentration is nothing but number of moles of solute present in the volume of solution. Number of moles of solute or amount of solute present in the volume of solution generally, that is called what? Concentration. Here concentration is equal to number of moles of solute present in the volume of solution. Here there are two methods are there to express the concentration. What is the? They are relative concentration and absolute concentration. In relative concentration we are not telling exact amount of solute present in a solution, but we are telling whether it is present in more quantity or less quantity. More quantity or less quantity. So the relative concentration or absolute concentration, this is also called qualitative method, and this is quantitative quantitative expression. So here qualitatively we can say whether it is a dilute solution and or concentrated solution, dilute solution and concentrated solution, dilute and concentrated solutions. So here what is a dilute solution? In dilute solution, less amount of solute, more amount of solvent. So what is that amount? We are not going to tell whether it is having less amount of solute or not. That is nothing but a dilute solution. And concentrated solution means that is nothing but having more solute in solution, more amount of solute in a solution, that is called concentrated solution. So this is about relative method of expressing concentration. Sometimes we write dilute HCl. Dilute HCl means here less amount of solute is present, more amount of H2O is present. And concentrated HCl means in concentrated HCl the quantity of HCl is more. Here the quantity of HCl is less when you compare to the when we can in absolutely in solution the quantity of solution is always greater, but here which is called dilute, very less amount of solute, and concentrated means which is having more amount of solute in a solution. This is about relative methods of expressing. Next, absolute methods. There are several methods are there. They are first one mass percentage. First one is mass percentage, second one is volume percentage, third one is mass volume percentage, fourth one is volume mass percentage, next fifth one is ppm, sixth ppb, pph. So all these are what absolute methods and still are there. Next eighth one is molarity, normality, molality, and formality. Next formality, next mole fraction. So these are the methods we use to express the concentration of solutions. So this is the mass percentage, volume percentage. This is mass volume percentage, Next, this is volume mass percentage. ppm, that is parts per million. pph, parts per billion. Next ppb is the parts per billion, pph parts per 100. Next molarity, normality, molality and formality and mole fraction. These are the 12 methods are there to express the concentration of solutions. So the first we will discuss about the mass percentage. So what is the mass percentage? First one, mass percentage or weight percentage. So here weight and mass both are same. Weight on the earth, weight and mass both are same, that is mass percentage. Mass percentage means the amount of solute or the mass of solute, the mass of solute, the mass of solute present in, the mass of solute present in 100 grams of solute, 100 grams of solution, 100 grams of solution, the mass of solute present in 100 grams of solution. So here how we can express mass percent is equal to mass of solute by mass of solution into 100. So we already know mass of solute, let us consider small w. Mass of solution, it is nothing but solute mass plus solvent mass into 100. So this is the mass percentage. So let us take one illustration here. Calculate the mass percentage of a solution. Calculate the mass percentage. Calculate the mass percentage of solution containing 50 grams of solute and 400 grams of solvent. So here mass percentage formula, that is, what is the mass of solute they given? 50 grams. Mass of solvent they given 400 grams. Here in the denominator we will take the mass of solute plus mass of solvent. So here 50 plus 400 into 100, that is equal to 50 by 450 into 100. So 0 will get cancelled. 45 by 50, that is, this is the 50 by 45 means this is the mass percentage. So when you simplify this, simply you will get 1.45 ones, 45 1.11 bar, that is the answer. So this is the mass percentage, 1.11. This is the mass percentage. This is about mass percentage. Next let us discuss about volume percentage. Volume percentage. Yes, next method of expressing concentration is volume percentage. So here what is the volume percentage? So volume percentage is nothing but the volume of solute present, the volume of solute present in 100 ml of solution. The volume of solute present in 100 ml of solution is called what? Volume percentage. So here volume percentage formula, volume of solute by volume of solution, into 100. So here what is the volume of solute? Let us consider small v. Volume of solution is small v plus capital V. Volume of solution means volume of solute plus volume of solvent. into 100. So now let us take here also one illustration. Calculate the volume of solute. Calculate the volume of solute. Calculate the volume of solute which contain calculate the volume of solute which contain 500 ml of 500 ml of 20 percentage 20% volume by volume solution. So here they given volume percentage they given and volume of solution also they given. So volume percentage V by V is equal to volume of solute by volume of solution into 100. So here, so volume percentage they given 20%. 20% is equal to V by volume of solution 500 into 100. So now 500 by 100 means 5. So therefore V is equal to 20 into 5, that is 100 ml. So the volume of solute is 100 ml. So in this way we can calculate the volume of solute. Next let us take one more illustration. How much of volume of solute is required? So that also same. Next we will discuss the mass volume percentage. Mass volume percentage. Mass volume percentage. Mass volume percentage. Mass volume percentage is nothing but the weight of solute. The weight of solute present in, the weight of solute present in 100 ml of solution. The weight of solute present in 100 ml of solution is called what? Weight volume percentage. So weight volume percentage, how we can write? Weight volume percentage is equal to weight of solute. Weight of solute. Weight of solute by volume of solution into 100. So here this is the, simply we will write weight of solute by volume of solution into 100. So weight volume percentage. So here also let us take one illustration. Calculate the weight volume percentage. Calculate weight volume percentage of solution contain 5 grams of NaCl in 450 ml of water. 50 ml of water. Okay. So now, or 50 ml of solution. 50 ml of solution. So now weight volume percentage is equal to, so what is the weight volume percentage formula? Weight of solute. What is the weight of solute? They given 5 grams. Volume by volume of solution. What is the volume of solution? 50 ml into 100. So that is, so 1 5, so 5 5 1, so here we will get 10 grams per ml. 10 grams per ml. This is the weight volume percentage. In the next videos, I will discuss the remaining methods of expressing concentration. So, thank you.